This is what we did last week. Question number 7. The graph below represent the successive ionization energy of element X. So any element is there, unknown element X is there, and the successive ionization energy means you are removing electron from the last shell and then you continue till you remove the electron from it. Then it is plotted against the number of electron which is removed. So this is when you remove first electron, second, then third, fourth, fifth, sixth, 7, 8, 9, 10, and 11. You can see here, because what happened for any element, when we remove electron from last shell, and when we change the shell, like example, when there is a change in the shell, there will be a big jump in ionization energy. Reason why there will be big jump in ionization energy, because electrons which are there in the last shell, they're far away from the nucleus. So we need a small amount of energy to remove them. But electrons which are closer to the nucleus, lower shells, so we need greater amount of energy to remove those electrons. So first thing, you have to identify which group it belongs to. How you can identify? Look, you remove one electron, then when you remove the second electron, there's a jump, there's a gap. But the thing is, when you remove the fourth electron, there's also a jump. So what does it mean? It means that this jump is due to change in the orbital. Why this jump is change in the orbital? Because, like example, if I remove electron from 2p orbital, I need smaller amount of energy as compared to 2s orbital. So when orbital changes, there will be a gap, difference will be there in ionization energy. But when the shell changes, there will be a greater difference in ionization energy. So how I conclude that this is due to the orbital, this is not due to the shell, because if it was due to the shell, then the other ionization energy should be in the order, means it should be like this, because the lower shell should have 8 electron. But what happened when we remove one electron, then when we remove the second electron, there's a small gap. Then third and fourth electron removed, they are in the same range order. Then when we remove the fourth electron, there's a big jump. And then you can see they are in the order. So when they're in the order, what it shows they're in the same shell. So how many electrons are there in the last shell of this element? How many electrons are there in the last shell of this element? These are the 3 electrons which are there, and this is the second inner shell. So how many electrons are there in the last shell of this element? There are 3 electrons in the last shell of this element. Now from this question, from this graph, it is possible to deduce the group of X from in the periodic table. So which group it belongs to? Because the number of the electron in the last shell shows the group number. So as we identify, because 3 of the energies are closer and then there's a gap, so shows that there's a change. Why this gap is there? This is because change in orbital. And why this other gap is there? It's because change in shell. And how I am sure that this is because of change in shell? Because the other energies are in the same order. So when they are in the same order, this shows that this is in the same shell and this was from other shell. So how many electrons are there in the last shell of this element? So there are 3 electrons. If 3 electrons are there, so this element belongs to group 3. Is it clear? From the graph, it is possible to deduce the most stable ion. So if it is a group 3 element, what will be the charge on group 3? group 3 tend to lose because the metal group 3 is there. So what group 3 tend to do? Group 3 tend to lose all of their valence electron. So what will be the stable charge or stable ion when they loses electron? So it will be X with a charge 3 plus or plus 3. Which change is atomization? What is the meaning of atomization? When we produce one atom, so when we produce 1 mole of atom in a gaseous state, what we call that as atomization. So which one is atomization? A, B, C, or D? So just you have to check in which one you produce 1 mole of atom in a gaseous state. So D is the right answer. Everyone should participate. Even your answer is wrong, it's not an issue. But when you show and when you participate, it shows your understanding of the topic as well. Like I can judge how much you understand from the explanation. The next question, which group this element belongs to? So you have to check this ionization energy. First it is 789, then it is double, which is about 1577. Then it's also double of 1500. Then it is 4300 and suddenly 16,000. So when suddenly 16,000, so what this gives an idea, this is a big jump. So if there's a big jump, that what gives you an idea? It gives that now the shell changes. So how many electrons are there in the last shell? Because 4 ionization energies are approximately like twice of each other. But then there's a big jump. When there's a big jump, what it shows that the shell changes. So if the shell change, how many electron in the last shell? 1, 2, 3, 4. So it means it belongs to group 4. Is it clear? So when you check these numbers, the ionization energy, there will be a big jump when you remove electron from another shell. So you can see the first number, 789. Then second one is 1500, approximately double. It's not a big jump. Then 3232, then 4356. But when you remove the fifth electron, you can see a very big jump. It changes from 4000 to 16,000. So this is a big jump. So what it shows, when there's a big jump in ionization energy, it shows that the shell changes. Means this is a lower shell, this is the outer shell, and this one is a inner shell. So how many electrons appear in the outer shell? Because there are 4 electrons appear in the outer shell. So what we can say? We can say that this element belongs to group 4. An isotope of an element which is having atomic number Z and has a mass number 2Z plus 4. how many neutrons are there? So this is atomic number is Z, and the mass number is 2Z minus 4 plus 4. So how to find the number of neutron? Number of neutron is equals to mass number minus, so the mass number minus the atomic number, you will get the number of neutron. So mass number is 2Z plus 4 minus the atomic number is Z. So when you solve this, 2Z minus Z, that's equal to Z. So N is equals to Z plus 4. So that's why A is the right answer. For question 4, question number 13, when aluminium is plus 4 ion is formed from an atom, the fourth electron is lost from. So it's better you write the electronic configuration to understand how the electron. So aluminium is atomic number 13. What is the electronic structure or electronic configuration of aluminium? It is 1s2, 2s2, 2p6, 3s2, 3p1. So when we remove the electron, removal of electron is always from the last. So first electron remove from 3p, then 3s, then also 3s. And from where we remove the electron? We remove the electron from 2p subshell. So what is the fourth electron is removed from 2p because we want to make aluminium plus 4. So what's the right answer? C is the correct answer. Is it clear? So in some versions of periodic table, hydrogen is placed in the same group as sodium. Give the electronic configuration of both hydrogen atom and sodium atom using S and P notation, and use this to justify or give the reason. So when we write the electronic configuration for hydrogen, because hydrogen is atomic number 1, so it is 1s1, and sodium is 11, so it is 1s2, 2s2, 2p6, 3s1. So why hydrogen and sodium are some in the periodic table, they are placed in the same group? Because you can see here both have same number of electron in the last shell. For hydrogen, actually first shell is the last shell, which is having 1 electron. For sodium, third shell is the last shell. So reason is that because both have same number of electron. In the last shell, that is why belongs to same group. Next, which element in the periodic table has the highest first ionization energy, and it's of 3 marks. So which element is having the highest ionization energy? As we discussed this ionization energy, that helium is having the highest ionization energy. Yeah, that's right. Helium is having the highest first ionization energy. And what is the reason for that? So 1 mark because of 3 marks. So how you will write your answer? The first thing, you will mention the element, name of the element. So that's helium. The second thing, because electron removed from the closest new shell, so electron is removed from the closest shell and it has no shielding effect, because shielding effect is refers to when inner shell electrons repel the outer shell electron, it will have a shielding effect. So because it does not have any shielding effect or no shielding effect, so due to this reason, we say that it is having the highest first ionization energy. The number of unpaired electron in nitrogen atom in a ground state. Ground state means like it does not lose or gain electrons in a normal configuration. So when we write nitrogen, draw the structure of nitrogen. So it is 7 and 14. So in terms of orbital, when we write, it is 1s2, 2s2, and 2p3. When we make electron in a box model, so 1s will have 2 electron, 2s will have 2, but 2p having 3, so singly they will occupy. So how many unpaired electrons are there? How many electrons did not pair up? So that's 3. Is it clear? Okay, question 19. In question 19, four sequence of ionization energy of element is given. Which sequence give the first ionization of element going down the group? So when we go down the group, the ionization energy should decrease because the size is increasing. So ionization energy should decrease as we go down the group. The first element will have 1 shell, the second in the group 2, then 3, and so on. Which series is giving a sequence, or which sequence is giving energy down the group? It should decrease. So you have to check this number. 590, then 1145, then 490, 4912, 6400, and 8144. So what is happening? In this case, ionization energy is increasing. So this cannot be, because as we go down the group, the size increase. So if the size increase, the ionization energy should decrease. When you check this one, 520, 496, 419, 403, 376. So for B, as you can see, as you go down, ionization energy should decrease. So all the values are decreasing. Why not this one? It's 1000 and 1200 and then suddenly down, increase and then it decreases. So it means this cannot be. So that's why B is the right answer. Is it clear? The first one? The second question, the sequence which show first 5 ionization energy of calcium. So first 5 ionization energy of calcium. So calcium is 20 and 40. So when we write the electronic configuration for calcium, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So means when we remove electron, the first electron is from 4s, then 4s, and then 3p. So means first two should be closer, and then there should be a jump. So there should be a jump from between the second and the third ionization. So you have to check which one give a jump from second to third ionization. So this is 590, 1145, and then suddenly there's a jump 4000. So what it shows means A is a calcium. The sequence showing the first ionization of successive element in which atomic number increased by 1 is starting from group 6. So means the first element should be group 6, then group 7, then group 8, and after group 8 you will come to group 1 and then group 2. So moving across the period, the ionization energy increase. So for first 3 element, it should increase, and then as you change the period, it will increase as well, but there will be a decrease when moving from third to fourth element. So which one is the right answer? The sequence showing that first ionization of successive element in which atomic number increased by 1 means group 6, then group 7, group 8. Group 8 should have the highest ionization, and then as moving from group 8, if atomic number increase, it means you will have group 1 again, or the next period group 1 element. So what will be the answer? So C will be the answer. You can see 1000, because the sequence is what they mentioned. Like if you have a periodic table, so these are the groups of a periodic table. Group 1 is there, 2, example group 3, 4, 5, 6, 7, and group 8. So example, they mentioned the first element should be group 6. So group 6, 7, 8, what will happen? It will increase. But then what happened as one more atomic number increases, so you'll move to another period. So as you move to another period, this element of group 1 will have a lower ionization energy than group 8. And moving from 1 to 2 across the period, again it will increase. So means for first 3 element, it should increase. Then there should be a jump or a gap. The ionization energy should decrease, and then it will increase. So first 3 element 1000, 1200, 1500, it increases. So it means this is group 6, 7, 8, and then this is group 1 and 2. So that's why for this one, 19C is the correct answer. Is it clear? Is this clear? Any doubt in this? Look, in the question they mention the sequence which shows the first ionization energy of successive elements in which the atomic number increase by 1 each time, starting with element in group 6. So the element which is there in a group 6, then next element will be in group 7 because atomic number increase, then next element is in group 8. If I add one more proton number, that element will be in group 1 again, and then group 2. So means when moving from element of group 6, 7 and 8, ionization energy will increase. But as atomic number increase from group 8 again, so you will have group 1 element. So it means moving from 8 to group 1 element, the ionization energy will decrease. And so means after 3 ionization energies, the four means there should be a gap between third and fourth ionization. So moving the third ionization energy value and the fourth ionization energy value, they should decrease. So you can see here it is 1000, then 1251, then 1521. So it increases for first three. It shows this is group 6 element, this is group 7 element, and this one is group 8. But what happened when it moved from the fourth one, the value is decreasing. Why the fourth one value is decreasing? It means it is a group 1 element. So ionization energy increases across the period, but as the period changes, the ionization energy decreases because as a successive atomic number, the ionization energy will be smaller. Is it clear now? And the calcium question, because calcium, the last shell, we need a 5 successive calcium ionization. Calcium is in the last shell, calcium is having 2 electrons. So means the first 2 ionization energy should be closer, but when we remove the third electron, ionization energy should be higher or big jump will be there. So you can see first example 590, 1145, and then 4912. So it's a big jump. So when there is a big jump, it means the shell changes. So this A is representing the ionization energies of calcium, or first 5 ionization energy of calcium. An atom of a silicon has a mass number of 29. Complete the table. Silicon atomic number is 14. So how many protons will be there? 14. How many electrons will be there? 14. And how many neutron? 14 minus 29. So that's equal to 29 minus 14. That's equal to 15. Then complete the electronic structure of silicon. What is the electronic structure of silicon? We have to arrange 14 electrons. So 1s2 is there. So 1s2, then it will be 2s2, 2p6, so 10 arrange, then 3s2, 3p2 will be there. This is the electronic structure of silicon. Explain the following by reference of a different in structure and a bonding. Why silicon has a higher melting temperature than phosphorus? So what's the reason when you compare their structures? So the reason is that, as you know, silicon having a giant structure. Group 4 element, silicon is giant covalent structure where phosphorus is simple molecular So it requires greater energy to break the bonds within silicon. That's why it is having a high melting point temperature. So silicon is a giant covalent structure where phosphorus is a simple molecular structure, and because there are more bonds in the giant structure, so we need greater amount of energy to break, like to separate them. Magnesium is having higher melting temperature than sodium. Both are the metals, but why magnesium? Because as we move across the period, the size of the ion decreases. So sodium ion, it's only plus charge. They both have the lattice of a positive ion and the free electrons. But sodium lattice will have a large ion, wherein magnesium, the size of the ion will be smaller, the positive ion. So they will have greater attraction or a binding, and the charge, because magnesium is group 2, so magnesium lattice, the positive ion will have +2 charge, where sodium lattice, the ion, the positive ion will have +1 charge. So how we explain this difference, why magnesium? So first thing you will mention, magnesium ions are smaller. Then what happens as the ions are smaller? So magnesium ions have greater attraction towards the positive ion, greater attraction towards the delocalized electron. More ions or more electrons for magnesium in the structure. So it has stronger or greater attraction. Is it clear? The reason? The reason why the magnesium is having a higher melting temperature than of that of sodium. Sodium ions are larger, so smaller, weak attraction towards the positive electrons, whereas magnesium +2 charges in the positive ions, so stronger attraction, small also, so greater number of charges as well as stronger attraction. Suggests why atomic radius decreasing going across the period from sodium to silicon. Like when we move across the period from sodium to silicon, why we observe that the size, like sodium is larger in size, then magnesium smaller, aluminum smaller, and it is getting smaller. What is the reason why the size is decreasing across the period? So what happened as we move across the period, there are more protons because proton number increase as we move across the period. So more protons are there. Attracting electrons from same shell. So greater attraction towards the nucleus, so size decreases. Because what happened, like example, if I draw sodium, so sodium, this is a nucleus of a sodium which is having 11 proton and 23 neutrons are there. First shell it will have 2 electrons, second shell it will have 8 electron, and the third shell it will have 1 electron. But when we draw magnesium, the same it will have 12 protons, and the same electrons, the third shell electron it is attracting. So as it is attracting electron from the third shell, so what we'll observe, same number of shell, but because there's a greater number nuclear charge, so more attraction towards the nucleus, that's why the size decreases across the period. Is it clear? Is it clear? The reason why the size decreases as we move across the period. The diagram shows the value of ionization energy of sodium and magnesium. On the diagram, add a cross to mark the position for aluminium. So if you remember that table, the trend, a pattern in ionization energy. So what is the pattern in ionization energy? Normal pattern. For first two element, it increases. Like group 1 element, then group 2, it increases. Then group 3, it decreased for group 3. Why it decreased for group 3? Because of shielding effect. Then group 4, it increases. Then group 5, group 6. So group 6 should be higher, but what we observe, it's not higher. It also decreases. Why group 5 and 6? Because of the pairing of electron in the p orbital. And then group 7 is there and group 8. So this is a pattern which it follow. So this is group 1 sodium and second is magnesium. So where aluminum will be there, it should be between magnesium and aluminum, between sodium and magnesium. And where silicon, the fourth element, will be there, it will be above. So if we are making for aluminum, it should be between, and if we are making for silicon, it will be higher. And why there is a dip here from second to third? That's because of shielding effect of different orbitals. Same shell, but different orbitals are used. Is it clear, this part? I'll continue this in the next session.